In this chapter, we've already looked at geometric sequences. We've also looked at compound interest and reducing balance depreciation, which are applications of geometric sequences. Now we're just going to kind of sum it all up with using rules to find the nth term. So initially, we have learned how to do it recursively. So that's what the first example here shows. It says calculate the value of a $1,500 investment each year, earning 5% interest each year. Okay, so we're being tasked with working out these ones. So pause the video and do it the fastest way on the CAS that you know how to do. So here we're going to get the initial value, which is 1,500, and we're going to times it by the multiplier, which is 1 plus 5 over 100, and this will give us 1.05 in the brackets there. Okay, now if we want to do that again, answer, and we're going to go times, and this time we're just going to use the decimal multiplier just because it's easier, and now you can hit enter 4 more times. And these are your answers, so I'm going to write them in now. Okay, so that's how you do it recursively. So that's called recursively, and you're expected to be able to do that 5 times. After 5 times, you'd be better off using a rule. So this is what this chapter is mainly about, is using rules to do it more efficiently. So for any geometric sequence which is being used more than 5 times, to find the value of Vn, we simply do the multiplier r to the power of n. So you get the original value. So this is the original value, or we're going to call it the principal. This is the number of compounding periods, and this is the value after n periods. So how would we use this to find the value of the investment, the original investment in the question, 1,500, after 20 years? So pause the video and have a go at that now. So here we will do V20 is equal to V0 times 1.05 to the power of 20, and that will give us the final value. So the answer should always be written. Okay, so that's how you do it using a rule for the same procedure. So this can be given a bit more detail if we look at the fact that there are different compounding periods. So r generally is 1 plus r over 100, but if we have different compounding periods in a year, we have to include this x term here. So this is the number of compounding periods in 1 year. So for example, weekly would be 52, fortnightly would be 26, monthly would be 12, etc. So you have to work out how many periods there are in 1 year. And that has to multiply the power as well. So obviously, because you'll be doing it more times, you need to multiply the number of times per year. So this is the number of years. Okay, and that's times x there and times x down there. So if you look at my previous video, I go through that in more detail. And therefore, the end equation is this one. Therefore, as a whole, if we put both together, we get this for the final formula, and it works for all compound interest questions. I should add, with no payments. Soon in the next chapter we'll look at when there's payments as well.